Alright, picking up where we left off here, we're going to start talking about other pairs of angles. Complementary angles. Why, thank you again. Our two angles are called complementary angles if the sum of their degree measurements equals 90 degrees. One of the complementary angles is said to be a complement of the other. So they have to be just two angles, and they have to add up to equal 90 degrees is the key to this. So notice that we've got two angles here. Their measurements are given. So if I just try and add their two measurements, if they add to equal 90 degrees, then those are what we call complementary angles. Or the 32 degree angle is the complement of the 58 degree angle. So right here we put them right back to back and they form a right angle. Another type of angle is supplementary angles. Two angles are called supplementary angles if the sum of their degree measurements equals 180 degrees. Alright, they're called the supplement of one another. So again, we have to have just two angles, and if their sum adds this time to 180 degrees, then they're supplementary. So again, if we put them back to back, they would be a linear pair because they would form a straight line, and we'd know that their measure was 180 degrees. So now we have a couple of quick problems or examples of this. It says find the complement of each of the angles below. So we know that the complement of angle E, if we added it to angle E, it would equal 90 degrees. So to find the complement of it, if we just take the 90 degrees, which is our total, minus our part, then we're going to get the other part. So let's take 90 minus 38.6. And we will get 51.4 for the complement of 38.6. Now this one's a little bit tricky, but if we keep in mind the same technique that we used on angle E to find its complement, then we're still going to take the 90 degrees minus the angle that we know, which would be the 7x minus 12, and we'll get its complement. So now we're going to have to use a little bit of the distributive property and distribute that negative throughout the parentheses. So we'll have 90 degrees minus 7x plus 12. So if I add the 12 and the 90, I'll get 102 minus 7x, and this degrees would be the complement of 7x minus 12. Any questions? No, Mr. Lane, but I want to compliment your nice shirt you're wearing. Well, thank you. Thank you very much, Mr. T. Alright, right now we're going to go ahead and pause the video, and you need to do problems 8, 10, 18, and 20 from page 31. So go ahead and pause the video and do that at this time. Alright. Now we have an angle is 10 degrees more than 3 times the measure of its complement. We find the measure of its complement the same way as we did the other problems from the previous page. Alright, so we're going to name our first angle, let's just call it angle A, let's just call it X. So then its complement, or angle B, would be 90 minus X. So now we're going to read one more time what our problem is. It says the angle is 10 degrees more than 3 times the measure of its complement. Alright, so we're going to list angle A as x is equal to 3 times the measure of its complement, or 10 more than that. So we're going to list 10 plus 3 times angle B, which would be the 90 minus x. So that's what I'm going to plug in to the parentheses here because it's a complement of A. So to figure out what x is, I have to multiply that 3 throughout the parentheses. So I'll have x equals 270 minus 3x plus 10. So I need to bring the x's to the same side. So I'm going to go ahead and add 3x to bring it to the same side. That's going to give me 4x is equal to 280. And now if it's x times 4, the opposite would be to divide by 4, which would then give me the x value is 70. So it looks like the angle of our first angle is 70 degrees, but I think it wants its complement. So if we plugged the 70 in for x for angle B, then we would get 20 degrees. So its complement would be the 20 degrees. Alright, this time go ahead and do problems 12 and 22 from page 30. And this is going to conclude part B of section 1-4.